Alrighty, so next we're going to be looking at the nth term of a geometric sequence. Now this is similar to what we did in the previous one when we were looking at arithmetic sequences. It's all well and good to be able to get from t1 to t2, but the issue comes about how do I get to t50 or t60. Now because of the way that the sequences grow, you're going to find that they're going to grow quite quickly, and so some of the answers we're going to get is going to be very, very big, very fast. So, two things in here. We want to be able to recognize geometric sequences, and then we want to be able to predict using them. And we're going to be using the general rule. Alrighty, so the general rule is Tn is equal to T1 r to the n minus 1. You'll notice it's got the n minus 1, same as with the arithmetic, but instead of multiplying, it's actually to the power of. So it's r to the power of n minus 1. Where once again, T1 is the first term, r is the common ratio, Tn is the nth term of the sequence. Alrighty, so that is the general rule, and it is one that is on our formula sheets, which makes it a little bit easier to remember. So, remember we want to recognize the geometric sequence and then predict using the general rule. So let's imagine we have a sequence of 30, 10, 10 thirds, and we wanted to predict the 10th term of that sequence. Well, first of all, we know what T1 is. It's just 30. R is just the division of two terms. So you got 10 divided by 30, which is a third. Good to double check though. So 10 thirds divided by 10, which is indeed a third. And from here, now we know that we're looking for the 10th term, so that's n equals 10. So, these first two steps confirm, yes, it is a geosequence. Right? If they didn't, then it wouldn't be a geometric sequence. Alrighty, so now we can actually predict using it. So, Tn is equal to T1 r to the n minus 1. That's the formula. Substitute everything we know in. Tn is equal to 30 times a third to the power of n minus 1. And that is our general rule. But we didn't just want Tn, we wanted T10. So let's sub in n equals 10. We get T10 is equal to 30 times a third to the power of 10 minus 1, and using a calculator. Now, my calculator has just done something, and your calculator might do the same thing, which is it's going to give us in scientific notation. So it says 5.08053 e to the negative 4, or you might see times 10 to the negative 4. Alrighty, mine in fact just looks like this, e to negative 4. And what that means is that it's scientific notation, and it means move the decimal point 4 places to the left. So 4 places to the left. So after doing that, you get 0.0000508. Right, because the decimal point was here and it's moved 1, 2, 3, 4. Oh, put it in the wrong spot. Should have gone here. So the decimal point was here and it's moved 4 spaces to the left, 4 to the left. 2, 3, 4. So that's all scientific notation. And you will get some scientific notation answers in this one just because the numbers can get so big and so small. So it's useful to be able to convert back and forth between them. So the 10th term would be that. Let's look at this sequence, 10, 20, 50, T30. Now some of you might be able to recognize immediately, but let's just double check. So T1 would be equal to 10, and the question is, what would R be? Well, 20 divided by 10 is 2, but always good to double check. R is equal to 50 divided by 20, which is equal to 2.5. These two things are not the same. Therefore, it is not a geometric sequence. And because it's not a geometric sequence, I can't predict with it, so I'm going to look at another one. Alrighty, so let's look at this sequence. 6, 30, 150, and we want to predict T15. So first of all, T1 equals 6, R is equal to 30 over 6, which is 5. Double check, 150 over 30, which is also 5. Therefore, it is a geosequence, okay? So if any terms do not give the same common ratio, then it's not a, not give the same common ratio, then it is not a geometric sequence. Alrighty, so let's try to predict it. So the general rule, Tn is equal to T1 r to the n minus 1. Tn is equal to 6 times 5 to the n minus 1. I like putting r in brackets. If you always put r in brackets, you're never going to make mistakes. It's really important when r is a fraction or negative, but just as a good rule, I like to always put r in brackets. So in this case, 5. Alrighty. But that's just the general rule. I want a specific value. I want it when n is equal to 15, based on that's which term we're interested in. So T15 would be equal to 6 times 5 in brackets, 15 minus 1. And using your calculator, you're going to get just a small little number. T15 is equal to 36,621,093,750. In other words, a very big number. We'll have a look at one more and then we'll be finished. Alrighty, so looking at this sequence, we've got negative 16, 48, negative 100, ... So T1 is just negative 16. The fact that it's switching between positive and negative means that R should be negative. Let's double check that. So R is equal to 40 over negative 16. That's equal to negative 2.5. Double check. Negative 100 over 40. That also equals negative 2.5. And we now know that it is geometric. And now we can predict. So Tn is equal to T1 r to the n minus 1. T1 is just negative 16. R is negative 2.5. Remember using brackets, n minus 1. And we're looking for the 20th term, so when n equals 20. And we get that T20 is equal to negative 16 times negative 2.5 to the power of 20 minus 1. And into the calculator. And in this case, we get quite a large number. T20 is equal to positive 582,076,609 point, and then a bunch of decimal places, and I'm just going to round to 134. Let's round that to 13. And that is the 20th term of that sequence. Alrighty, so we've had a bit of practice, and I'll see you in the next one. Goodbye.